3.5 is on transformations of the function and graphing using transformations, and now we're continuing with exploration 5. So far, what we've seen are the vertical and horizontal shifts in transformations, the vertical stretches and compressions, the horizontal stretches and compressions, and our last type of transformation has to do with reflections. Reflections about the x-axis and reflections about the y-axis. Okay, so this time for this particular transformation demonstration, we're going to use the parent function of the square root function. We could use any of them, square function, the absolute value function, but in this case we're going to use the square root. So we're to graph each of these. Now recall the square root function we have a restriction on our domain, because we do have a radical of even index. To find the domain of a function, start with all real numbers. Then, if you have a variable in the denominator, well, we don't, so we don't need to look at condition number 2. Condition 3 was, if you have a variable under a radical of even index, we have to exclude all values for x that make this radicand negative. So that would be anything less than 0. 0 would be fine, but anything less than 0. So we know we cannot put in, as I've been choosing in the other explorations, -2, -1. We won't be using those for x. So we can put in 0, and when we take the square root of 0, we get 0. So 0, 0 is on the graph of f of x equals the square root of x. When we put in 1 for x, we take the square root and we get 1 for f of x. And for the next x I'm going to choose, of course, I want to choose a perfect square because I'd like to get an integer. So the next perfect square after 0 and 1 is 4. And when I put in 4 and take the square root, I get 2. And we can get as far as 9, right? The next perfect square is 9. Put in 9 and take the square root, and we get 3. So here is our parent function for the square root function, our f of x. Okay, now we are to find g of x and graph g of x equals the opposite of, or negative, square root of x. So let's make a table like we've been doing with our other explorations. And for x, again, I can only choose positive or 0 values. So 0, 1, 4, 9, and I'm going to purposely choose perfect squares. Okay, when I put in 0, I take the square root of 0, I get 0. And then it has the opposite of 0, but 0 has no sign, so we just have 0, 0. When we put in 1, we get the square root of 1 is 1, and then apply the negative. Put in 4, the square root of 4 is 2, apply the negative. Notice this is done after we finish the parent function. We take the square root of x, then we do the transformation. Take the square root of 9, get 3, -3. So let's see what this looks like. 0, 0. 1, -1, 4, -2, and 9, -3. So here's where we are for our g of x. So this is the topic on reflections. So you'll see the parent function has reflected about which axis? Yes, the x-axis. Reflected about or over the x-axis. Let's see what happens if now we take that transformation from outside of our parent function and put it inside our parent function. Now this one might look a little bit funny because we see a negative under that radical. But what do we have to do to make this work out? What we take the square root of has to be 0 or a positive number, right? So if I put 0 in for x, -0, there is no such thing, so it would just be 0, and the square root of 0 is 0. I can't put in 1 because I'd be taking the square root of -1. So what could I put in to make this work? I could put in -1 for x, then that would change it to positive. The opposite of -1 is +1, and the square root of +1 is 1. And I could put in -4 because that double negative would make it a positive. Square root of 4 would be 2, and -9, and I would get 3. So where are we now? Again, 0, 0. Now -1, +1. -4, +2, and -9, +3. So now for our h of x, this is where we are. We're talking about reflections, and now which axis have we reflected about? The y-axis, right? So when we had our the transformation inside the parent function, what that changed was, for each one of these points on our original function, their y values didn't change. This point was at 1, 1. It's at -1, 1. So the y coordinate hasn't changed. What has changed are the x coordinates for those points. We'll look at a summary here in our next video.